All right, in this lesson, we are solving exponential equations. And so we're going to start with a warm-up, an easy warm-up. Number 1 says 2 to the x power equals 2 to the third power. And so obviously x would just be 3 because the base is the same, so their exponents have to be the same. So x equals 3. Okay, and so this next one, we have 2 to the x equals 8, but we could rewrite 8 as 2 to the third power. And so really this is the exact same equation that we just solved. X has to be 3. Okay, and so for number 4, we can do a similar approach. We can rewrite 16 as 4 squared. And so now my equation says 4 to the x plus 7 equals 4 squared. So this x plus 7 has to equal 2. If the bases are the same, the exponents have to be the same in order for these to be equal. And so now we can subtract 7 and get x equals -5. So that's kind of the goal when solving these. And this usually comes up on non-calculator tests for PSAT and SAT, is you try to get a common base, okay? And so here we had a common base of 2. Here we had a common base of 4, okay? And so your first step is to write each side using a common base and then set the exponents equal to each other. And then you would just isolate the variable. You could be left with a linear equation, sometimes a quadratic equation. So we'll see a couple of different examples. So on number 1, I can rewrite, I look at the smaller number, and so here 3 is our base. And luckily, I can rewrite 27 as 3 cubed. Now that the bases are the same, we set the exponents equal to each other. And then isolate x, we get 3 halves. Okay, for this next one, my current base is 5, and we can rewrite the 125 as 5 cubed. Okay, and so now my exponents have to be equal. 2k plus 7 equals 3. Isolate k by subtracting 7 from both sides. And then dividing by 2, we get k equals -2. Okay, on number 3, our smaller base is 16, and 64 is not a power of 16. But 16 can be written as 4 squared, and 64 can be written as 4 cubed. Okay, and so when I do that, I still have my other exponent, x plus 3, and that 2x. So using our rules of exponents, when you have 2 exponents on one base, they get multiplied. Okay, and so now my common base is 4, and I can set the exponents equal to each other. Okay, and so 2 times the x plus 3 is going to equal 4, oh, that's the base, 3 times the 2x, just setting those exponents equal to each other. So on this side, we distribute our 2 and get 2x plus 6. This side, we multiply 3 times 2 and get 6x. Then we can subtract 2x from both sides. Divide by 4. And that simplifies to 3 over 2. So 3 halves is our final answer. Okay, for this next one, we have a base of 5. And then over on this other side, we have a 1 over 25. And so the first thing I want to do is rewrite that 25 to the -1 power so that it's not a fraction. We want to use exponents. And now we have a base of 25. And so to make our 25 and 5 match, we can rewrite 25 as 5 squared. He already has this -1 and the 2n together, so we're going to have to multiply by -2n. Okay, and so now that our bases are the same, we can set our exponents equal to each other. 2 times negative 2n equals n minus 5. So negative 4n equals n minus 5. We can subtract n and get negative 5n equals negative 5. And so n equals positive 1. Okay, here we have an exponential expression here in the parentheses. So our first step now is to isolate that. So I'm going to subtract 5 from both sides. And then divide by 2. Just isolating the base. Our base is 3. Okay, and so now that I've isolated the base, I have 3 as my base, and I can rewrite the 27 as 3 to the third power. Okay, and so now that my bases are the same, I can set the exponents equal to each other. So that means r plus 7 equals 3. Subtract 7, we get r equals negative 4. Okay, same thing here. We have to isolate our exponential expression. Our exponential expression is written in parentheses. We see that the base is 4. And so our first step is to subtract 9. And then we would multiply by 2. To get rid of the 1/2. And then now our base is 4. And we can rewrite the 16 as 4 squared. And so now that my base is the same, I can set my exponents equal to each other. And then add 5. And so a equals 7. Okay, on this next one, we have a fraction again. So our first step is to rewrite that fraction with a negative exponent. So 1 over 27 is 27 to the negative first. And then I can rewrite 27 as 3 cubed. So that's technically 3 to the negative third power. Okay, and so from there, we're ready to set our exponents equal to each other, which in this case is giving us a quadratic equation. We have x squared plus 4x minus 3 equal to 0. Oh, just kidding. We have equals negative 3. And then whenever you have a quadratic equation, you want everything on one side so you can try to factor. So x squared plus 4x plus 3 equals 0. And so two numbers that multiply to 3 but add to 4 are 1 and 3. So this factors to x plus 1 and x plus 3. So that means my solutions are x equals negative 1 and x equals negative 3. Two solutions from this quadratic. All right, for number 8, we have a base of 2. And there's no way to rewrite 15 as a power of 2. And so you won't always be able to get a common base. You always want to try, because then you don't need a calculator. But in the case where you can't, you're going to need a calculator. And so your first step is to isolate the exponential expression, and then you're going to convert it to logarithmic form, and then isolate your variable. And you may need to use your calculator to get a decimal approximation. Okay, so here we already have our exponential expression isolated, so we're ready to convert to logarithmic form. Okay, and so this is base 2, so I like to make the loop log base 2 of 15 equals 3n. Log base 2 of 15 equals 3n. Okay, and remember, we're still trying to solve for n, so we need to divide by 3. And so sometimes on a non-calculator, they would just leave your answer in terms of log, which I've seen on the SAT. If you do want to get the calculator approximation, you can, if you have an updated TI-84, you have a button for log, but that's common log. That's log base 10. If you want a different base, you're going to have to use the keys math, alpha, math. Math, alpha, math. So math, and then if you press alpha and then math, it'll get you a log that you can type in any base. And so I'm typing in log base 2 of 15, get out of the parentheses to divide by 3. And so this is approximately 1.3. Okay, this next one, similar situation, 8 to any power is not going to give me 48. We can even drop down to 2, but then 48 is also not a power of 2. And so try to get a common base, and if it's not working, that's when you can convert to log. And so log base 8 of 48 equals 2k minus 5. Okay, so now we still have to isolate k, so we would add 5 to both sides. Log base 8 of 48 plus 5 equals 2k. And then our last step, divide everything, that whole expression, by 2. And so if you're leaving your answer in terms of log, you would have log base 8 of 48 plus 5. 48 and then plus 5. And then divide all of that by 2. And so to type that in your calculator, the best way to do that is to go ahead, if you have the shortcut key to get the fraction, it's alpha, y equals, enter. And then you can do math alpha, math base 8 of 48 over 2. And so that's approximately 0.93. Okay, and so to get this fraction bar, it's alpha y equals, and then to get this log base 8, that's math alpha math. Okay, for this next one, we have to first isolate our exponential expression. So our exponential expression, our base to the exponent is right here. So we first have to subtract 5. So 3, 5 to the n minus 7 equals 255. And then divide by 3. I'm not sure I know what that is. Divided by 3, 3 times 7, 21, subtract 75. And then if we try to rewrite 75 as a power of 5, we can't. And so this is when we know we have to convert. So log base 5 of 75 equals n minus 7. Log base 5 of 75 equals n minus 7. Now we just add 7 to both sides. So log base 5 of 75 plus 7 equals n. And so if we want the decimal approximation, we can do math alpha math. Log base 5 of 75, get out of the parentheses, plus 7. And so that is approximately 9.68. Okay, here we see E as our base, and so you're definitely going to need a calculator or to leave it in terms of natural log. And so here our base is E, our exponent is 4K equals 29, so we're ready to convert. log base e of 29 equals 4k. So remember, every time you're tempted to write log base e, you're going to do ln instead. Log base e is natural log of 29 equals 4k. And then divide by 4. And so k is natural log, that's ln, not in. I see that all the time. Divided by 4. And so to get that from your calculator, there's actually a button for it. There's an ln button, and so you would type the 29 and then divide by 4, and that's approximately 0.84. Okay, last one, we do need to isolate first. Our base is e, and so this 3 is being multiplied. We first would have to divide both sides by 3. E to the 7x plus 1 equals 81 divided by 3 is 27. Now we're ready to convert. Log base e of 27 equals 7x plus 1. So log base e is natural log ln of 27 equals 7x plus 1. Going to subtract 1 from both sides. And then divide the whole thing by 7. And so if you're leaving your answers in terms of log, you would write x equals natural log of 27 minus 1, all of that being divided by 7. That's important because they'll have a lot of distractors where it's not all being divided by 7. And then for your decimal approximation, that's when we would use the alpha y equals to get the big fraction. Enter. And then your natural log button, 27, close parentheses, minus 1. And then in the denominator, 7. And so we have approximately 0.33.